Good morning and welcome to day 3 of the Learning Ideas Conference 2021, our 14th annual conference. First, under the new name and expanded focus, I'm David Brownlee, the conference chair, and I'm glad to be here with you once again for our next full day of activities. So it's a lot going on, and I'm gonna walk you through a couple things as we get the day started. So it's really good to see everybody. All right, so I want to welcome you back once again, and a couple of things on sort of the housekeeping side. As we go, please feel free to tweet about the conference using the Learning Ideas Conf hashtag. Conference team again will be on Twitter with the handle Learning Ideas Co, because there are not enough letters allowed in a handle, I think, to be Learning Ideas Conf. Sessions are running in Zoom, accessible from the Hoover platform, as you've seen all week. As you have questions or comments for our speakers, please post them in the Zoom Q&A. I think most speakers tend to wait to the end to get to them, but you never know. So look forward to more participation. Couple of brief scheduling notes. We do have a cancellation for today, which is Patrick Wienhoff is unable to be here for his 1:30 talk in stream 3. So we'll still have, of course, 2 things going on at 1:30 this afternoon as planned. We also have one change. Lucia Steyer's talk on how to design compliance training that's engaging for frontline workers, and that was planned to be on Monday, and she ran into some technical issues and was not able to present. And so she did agree to come to a new slot, so Thursday at 4:30 p.m. on stream 2. And so all of these changes are reflected on the website and in the Hoover platform. And so we all should be all set there, and looking forward to her talk, and hopefully we'll see Patrick back again next year. All right, and I think we've covered the other items. So I want to talk about a couple of other things before we get to our opening keynote. Right, and so what I want to talk about is what we mean by learning technologies, and historically, we've seen different things in terms of technology. So let's look at what we mean by learning technologies in the way that I see it now. It's kind of an old model of learning technologies, which I think is based around the idea of taking educational models that we're familiar with and using technology, right? I mean, the simplest example of that to me is what everybody had to do in the pandemic so quickly, which was take a classroom course and put it on Zoom. And that was out of necessity, right? And there's really nothing else people could do. But we can certainly do better than that with more time. Totally understand why there was nothing else that could be done when you had about a day to make a decision about how you were going to handle things, and everything changed in a moment. So, but in general, the old model to me is basically, it's learning theory and there's technology, and there's kind of intersection, and that's what people consider learning technologies. And that's really not my own view of what learning technology should be or ought to be. Even if you have some learning theory in there, it's not just applying it to a new technology. It's not just thinking about how do I take a class and move it online, or even how do I take a class and replicate it into an online format. It's a very, very different thing. The new model to me looks a little bit more like this. You've got a bunch of different things, and I probably don't even have them all. I'm sure all of you would add some things that could go into this model. Learning theory, of course, is one. Technology, computer science, user experience design. We've talked a lot about learning experience design already here at this conference. And cognitive science. So, cognitive science research, other things from other areas. You take all of these up and you kind of mix them together, and you get learning technologies, along with creativity, along with writing and scripting and inventing new ideas and all of that. And to me, that's really what learning technologies means. It's not just taking technology and applying it to learning, but how can we best use technology for learning, right? So when I saw a virtual reality example yesterday of a really, in-depth VR, experience, that's a great example of how we can use a new technology for learning. Put you in a realistic environment, try something out, get feedback, see real consequences. This was basically a building that you could blow up if you did the wrong things. And then the example that we saw yesterday, those are consequences that you don't want to have in real life. You want to make sure people are well trained before they are in a position where they might accidentally blow something up. But you can experiment or make mistakes in a safe simulated environment. So again, that's not just taking a class and moving it to different technology. It's taking a class taking the new technology and thinking about what we can do educationally with it. I'll take one step back. I've mentioned this a little bit more at other times in this conference. Apprenticeships were really a good model. Apprenticeships go back years and years and years, as we can see, back to ancient Babylon and possibly before. So in these times, they were doing apprenticeships. How about that? Which is a great model. You would learn from an expert. You would work closely with the master craftsman, learn the job, start by doing simple things, move to more complex tasks. You had coaching, guidance, you had feedback if you did the wrong thing, you formed a relationship and sort of an emotional connection. And it was very much learning by doing, right? So all of the things that we see in progressive educational theory, project-based learning that work really, really well were part of apprenticeships. But the issue with apprenticeships was always that when we had to train a mass number of workers and then a mass number of people and teach a mass number of people, it just doesn't scale up. There are not enough experts. It's too expensive. People don't have the time. And that's, really what, got us to the kinds of mass education models that we see. And the amazing thing is that now with technology, we don't have to do that. We can build things at a large scale that are individualized with AI and AI techniques, that are immersive with VR and AR, and even great online experiences that have guidance and feedback and all of the things that apprenticeships have, and that scale up. You build this great environment for one person, you've built it for 1 million people or 10 million people, for the most part. And again, that's one of my own goals in having this conference, of bringing this group together, is to continue to push ideas in that area. Another thing to think about as we continue to talk about new technologies and ways that they work. Historically, whenever there's new technologies, it's sort of like a gap period where it takes time for people to fully adjust to what they want to do with the new technology. You're used to old technology, right? So, you look, I was not around at this time, but if you look back at some of the early television shows, they were, radio-like shows, right? It was, well, there's a picture, but maybe not as creatively thinking yet about what we can do with pictures, right? It's a radio show, but you can see me talking. And so there are always exceptions, but it's, really a different world in the early days than now, because every time we have a new technology, it takes some time to adjust. But each technology has its own different ways of working with us and its own different, interface elements and affordances and all of that. So radios gave you sound, right? You could, play sound anywhere, not from a person who was in the room with you, which was, again, I was not around in those days either, but it was a pretty cool thing. Then we had TV, so you had video. You could have a picture to go, with your sound, which was really, really something. And then that evolved over time as well. The original, early TVs, you had to, get up and change the channel. I remember when I was a kid and we had a remote on one of our TVs, and that was really, really cool. It didn't do very much, but it was a remote control and you could change the channels. And, you look back now and imagine, like, how could that actually be like a, new and cool thing? But it was. But then, later on we had VCRs, right? So we could record, we could time shift, we could fast forward, rewind, replay. That's a major thing, right? You could watch when you want, and you could control the watching experience, right? Television, you can watch when the show is on, and, in early TVs, there's nothing you could do, right? You want to watch a show that's on at, 7:30 at night, it's on from 7:30 to 8 o'clock, and you watch it, and that's about it. So, that's kind of how it would go. With time shifting and control, it already became a different world. But those are different interfaces, different things that you could do. So if, for example, someone had decided to design a program for VCR use, you might have thought of some different things that you could do. I don't think that ever happened. Well, someone probably did it. Mostly VCRs were used for showing movies and TV shows and taping things yourself and all that. But you had the opportunity to do that. And then later with DVDs, people did a little bit more with different bookmarks and things like that, and taking advantage of the technology. All right. So what's next? We have other forms of with interfaces. Video games had all kinds of different interfaces, right? Joysticks and all kinds of different controllers. And then get to the modern times, we had computers, and it was a big thing when the first Macs came out, and the idea of having a mouse and a graphical interface was mainstream. That was pretty cool and a new thing. We have laptops now, we have phones and tablets, time goes on, but each time we introduce a new technology, we can do different things with it. And we, as learning experience designers, have the opportunity to take advantage of those abilities to create different things, not necessarily just take existing models and bring them on to the old technologies. So kind of where I want to go today, and that leads me to our keynote speaker. You saw there was a little, I'm gonna go back to this slide for just one second. There's a little arrow down at the bottom of the slide, what's after smartphones and tablets? And we're already talking a lot about what's after smartphones and tablets with VR and AR and holograms and some of the things we've already seen here. But we're gonna take that a step further. With Dr. Ilona Buchem, who I'm so pleased to have with us here today. She's coming to us from Berlin. She is a very, very experienced professor of media and communication, leader of R&D projects on technology enhanced learning. As you can see, she's chair of a special interest group on wearable enhanced learning, actively involved throughout Europe in technology enhanced learning groups. And she has a book out. She is the editor of the new book, Perspectives on Wearable Enhanced Learning, Current Trends, Research, and Practice. And I think that makes her the most familiar person and the leading expert on wearable technologies in learning, and we're absolutely delighted to have her. So we're going to talk about wearable technologies, which is just a fascinating thing to talk about and what we can do with them in learning. And I'm so glad to have Ilona with us, and I'm going to turn it over to her. She's going to talk about wearable enhanced learning, trends, opportunities, and challenges. So please welcome. I know we can't hear you welcome, but please welcome anyway, Ilona Buchem. And Ilona, I'll turn it over to you.
Thank you, David. I'm glad I found the room, and I'm here and happy to see there are 13 attendees attending the session. I think we still have like 2 minutes to start, so maybe some people will join. I'm going to share my screen now, and hopefully this will work in a second. So thank you very much for this and for this very nice introduction about the history of technology enhanced learning, basically. So, oops, that's not where I wanted to. How can I go back? 1 second. Like this. My keynote is dedicated to wearable enhanced learning, and I'm going to talk about trends, opportunities, and challenges. And I think it's a fascinating topic because, like we saw in the timelines and David just presented, there are new technologies coming up, emerging technologies that are developed somewhere else, actually, a lot of times in other fields. These technologies offer so many opportunities that we can exploit, use them, utilize them to support learning. So wearable enhanced learning is just one of those technologies that are very oftentimes developed, for instance, in healthcare or in the games industry that we can enhance, that we can use to enhance learning. So like David mentioned, I am part of a special interest group at European Association of Technology Enhanced Learning. And the special interest group is called Wearable Enhanced Learning. And we found an acronym for this, which is WELL, WELL. And we use this acronym because, like I mentioned, many times wearable technologies come from the health medical field. For instance, if you think about the different fitness trackers, the sensors that enable you to monitor your viable parameters, for instance, those are very oftentimes technologies from those medical fields. And the acronym WELL was coined to enhance this idea that we could use those technologies to support the well-being of learners, not only learning as maybe you could think on cognitive level, for instance, or not even on the social level, which is, again, very, very important, but also on the level of supporting the well-being of learners. We published a book, which is called Perspectives on Wearable and Enhanced Learning, and we invited authors from different parts of the world to contribute their research, their development on using, or their case studies on using wearables to enhance learning. And I'm going to present some selected things from the book because the book is rather thick and there are many interesting use cases, how wearable technologies can be applied to learning. I just have chosen a few of them for today's keynote. So why don't we just start in an academic way with a definition of wearable enhanced learning? We propose this definition in our book as a specific type of technology enhanced learning, which applies wearable sensors and also wearable devices, which can be worn both on the body, but also in the body of the learner, and are in some way embedded in the environment of the learner. So when you think about wearables, maybe you just think about technologies like fitness trackers, for instance. Those are very popular technologies that many people use nowadays, but they're also, especially coming from the medical field again, possibilities of using wearable devices implanted, for instance, in the skin or somewhere else in the body, for instance, to biotrack specific data. And another important part of this definition is that those sensors and devices are embedded in the environment. So it's not only about the user as a system, but also the interaction between the user, the body of the user, and the environment that is really important in wearable enhanced learning. So I don't know what kind of idea you have about wearables, if you already use them, maybe you already apply them for learning. But here's just a nice overview from a NUNAG group, from a publication of the NUNAG group, which segmented the different uses of wearables in a nice visual way. So if you think about wearable technologies, there are specific technologies that are used in sports and fitness, like the fitness trackers you can use, for instance, on your wrist. There is another segment, the infotainment, with, for instance, smartwatches and other devices like head-mounted displays that can be used for gaming, for instance. But there is also this important medical segment with very many different sensors and devices that can be used to support learning. So just a brief overview of the different segments that there are in wearable enhanced technology. In our book, we have also had a look at how technology enhanced learning developed through time and proposed also a timeline. We took a little bit different view at how this has developed, maybe less from the perspective of the different technologies that have been applied, but more from the perspective of the goals that were followed by applying technologies to enhance learning. So in our book, we say we could distinguish between technology enhanced learning 1.0, which was about digitalization. And the aim of this phase in the history was to support more one-to-one, peer-to-peer communication and learning more on the bilateral level. The second phase, which we call TEL 2.0, was more about scaling, like using, for instance, the different standards for learning content, to distribute this content to make it more scalable, but also designing the different platforms like learning management systems, which enabled us to scale learning, scale instruction to a larger number of persons. And also the different hardware pieces like PC and laptop that enabled, for instance, every learner at school or at the university to have access to, for instance, digital content. The third phase, technology enhanced learning, in technology enhanced learning, we call it adaptation, which we think is the phase in the history where people started using or adapting technologies to individual needs, where we see beyond scaling also the personalization, for instance, in terms of which apps, which widgets to use to support individual needs of the learners. Also, this whole idea of learning analytics, personal learning environments, all the different technologies that we use to explore the different needs and also to cater to those different needs. And this final phase, which we think that we are now in, we call disintermediation, which is a term from economic sciences, and basically means that we get rid of the intermediaries. And we think what we can observe nowadays is that a lot of times the producers of the software and hardware can directly link to the customers or to the learners, and there's no more the need for intermediation also in the sense of educational institutions, and this has been also critically discussed in many places, this intermediation in education, under the heading of do we need to get rid of, for instance, schools and universities. And when you think about it, all these technologies, which also include wearable technologies, enable learners even more personalization and more independence from intermediaries, because they basically support the learner where he or she is with the technology that is produced on scale as a consumer product. So this is our alternative vision or version of the timeline of technology-enhanced learning. So in this phase at which we are now, we can observe that there is a trend and interest in using wearable devices and wearable sensors to support learning. And we think that in our research group, we think that wearable devices, wearable technologies have specific affordances that support learning in a different way than desktop and mobile technologies did. So first of all, wearables can be worn somewhere on the body, which automatically makes your hands free. So you can do something while you're wearing the device, you can do something with your hands. You don't have to carry, for instance, a smartphone with you. You can, for instance, if you think about a scenario working in the factory and learning how to work on a machine, you can actually interact with a machine in the physical space and still get, for instance, the information and the feedback that you need, for instance, through augmented reality glasses. You also can get contextual information and guidance, which means that those technology enable you to learn in situ, in context. Learning with wearable technologies can be also easily integrated into daily routines, and we can also provide learners with unobtrusive feedback. For instance, we can display some information on the smartwatch or through vibration, for instance, of e-textiles and so on. So this feedback can be much more unobtrusive than in case of desktop and mobile learning. Also, wearable technologies enable us to follow some specific pedagogical objectives that can be even more realized to a fuller or the fuller potential can be exploited. For instance, when we think about seamless learning in terms of crossing the boundaries of place and time, this can be much more easily done with technologies that you wear on your body than the technologies that you have to take with you, carry with you, install somewhere, plug in, and so on. The wearable technologies, especially the head-mounted displays, enable us also to realize the full potential of immersive learning. We can also support experiential learning off a screen when people interact with the environment, interact with other people, and also embodied learning, which is taking into consideration bodily processes, bodily feedback, bodily or enhancing bodily awareness. This can be very nicely supported with wearable technologies. Here are some examples of interesting wearables that were not developed for learning as we may think of in terms of formal education, but these technologies can support learning in informal context. So for instance, there is a number of interesting innovations in the field of e-textiles and smart garments. So for instance, if you practice yoga and you want to learn yoga, which is for instance your informal learning activity, you could wear smart yoga pants, which give you feedback in form of vibrations, and also they monitor the data while you are exercising, and they give you also an overview of the data after you have completed certain exercises. Then another one is another invention, the smart insoles, which you can put into your shoes. They have different sensors, like pressure sensors on the different parts of the insole. And those insoles provide real-time data and can be used to support learning of sports like golf, for instance, or there are special insoles to support learning of professional runners, for instance, or marathon runners who can monitor their data, monitor how they place the food on the ground and how they can improve their running style, for instance. There are other technologies like the posture tracker, for instance. Like you can see here, something you can just put at the back, on your back or at the back of your neck, which provides you also real-time data about your posture, and you can learn how to, for instance, sit or stand without slouching. Then you have smart gloves, which are employed in the industry, for instance, for people working in the warehouses. They have different readers that automatically scan the codes, for instance, in a warehouse. Or there are even smart earrings, which have different sensors in them, can be used, for instance, to monitor heart rate or the calorie intake, and can also monitor daily activities, like the fitness trackers, for instance, do, like a wristband that you would wear, the similar functionalities that you can find in some of the smart earrings that are produced nowadays. So basically, we can put the smart sensors anywhere into a piece of garment, into a piece of textile, or a gadget that you can put somewhere on the body to support learning on different levels in more informal contexts. In my own research projects, we have applied different technologies. So I'm going to talk about two of those projects. One was called FMOOC, which was Fitness MOOC for senior learners, where we applied fitness trackers. It was actually my first project with wearable technologies. And the second one is the BeWear project, in which we design exercise games in AR, VR, also MR, for senior patients with hypertension. Both projects are sponsored by the German Ministry of Education and Science. So in the first project, the Fitness MOOC, the idea behind this project was, how can we enhance learning about healthy aging without putting people in front of the screen? Again, this would be just sitting in front of the screen and not actually doing healthy things. So by integrating fitness trackers into the learning system, we could encourage senior learners to learn off the screen, learn with a computer in the context in their daily life about, for instance, the number of steps they did a day, the different activities they did, how this all accumulated, what it means for healthy living, how not to cross specific boundaries. People can also over-exercise, for instance. So there are different aspects that are connected with this. And it was interesting to develop all these different concepts and to think about also the connection of, for instance, the LMS, the learning management system, and fitness trackers, using the APIs, for instance, for data transfer, how this data can actually be transferred from the fitness tracker to the learning management system, how it can be visualized to the user, and what you can do with this data to support learning. So what we did, we combined this, the wearable trackers with gamification approaches, and we did, for instance, things like challenges, daily challenges that were visualized in the learning system. Here you can see some screens from the application that we developed. It was the back end of this application was actually LMS Moodle, which is very popular in higher education. And we had some battles, for instance, that were very popular between male and female learners. And through this, we were just experimenting, exploring the possibilities of using the data from the fitness trackers for learning. How can we enhance the reflection, the learning, also the motivation to live healthy every day, instead of just learning about living healthy by reading things on the screen. The second project that we are doing now is the BeWear project, in which we design XR gaming with AR and VR glasses, and we use different trackers there, eye trackers, heart rate trackers, and also smart insoles. So for instance, we're now developing a prototype for practicing Tai Chi with smart insoles. Well, the balance on the body is very important, how you put your feet. For instance, for older people, it can already be challenging to stand on one foot. And we're exploring new possibilities, how we can actually design exercising, sports rehabilitation for specific audiences, like the elderly with hypertension, in a new way. So what we saw here on this slide was one of our study participants with the controllers with the HTC headset. And what you see on this slide is what the learner actually sees. We developed a series of exercise games. One of them is about dancing. And again, combined with gamification, we developed an application where, or a game where users are challenged to dance like John Travolta in the disco of the 1960s or 70s. And yeah, this proved to be a very nice and fun concept for senior learners to practice and exercise at the same time. Okay, so these were just some examples, and I would like to touch upon the trends and opportunities and challenges of wearable enhanced learning. So let's start with some trends. Of course, I have mentioned this a number of times today. An important trend when thinking about wearable enhanced learning are the sensors. There are many, many sensors that can be used, that are used in different gadgets, but also can be used to design new gadgets, new wearable devices, for instance. So as this picture here shows, the sensors can be used, applied in headbands, in social metric badges, in camera clips, in smartwatches, in sensors embedded in clothing or in insoles of the shoes. And those different sensors that we use are basically, except maybe for the accelerometer and gyroscope, a lot of times, and proximity sensors, a lot of them are focused on capturing biodata, different biodata. Another trend, the second trend, which is interesting in terms of where wearable enhanced learning is developing, is the do-it-yourself trend. So all these sensors that are produced by different large companies, small companies, can be used to create own wearables, own wearable enhanced learning scenarios, experiences. So there are more and more maker communities. For instance, PappLab offers many workshops where people would use different sensors to design their own devices. This type of approach to creating wearable enhanced learning experiences is also about being creative, about prototyping. There are more and more R&D projects being funded. And also an interesting trend is connecting to the world of art, to artists, and making wearable enhanced learning to a more even artistic and aesthetic experience, for instance. Also, because of this do-it-yourself trend, there's startups producing new products being funded on different platforms with new interesting gadgets, like we saw, for instance, the smart earrings and so on. There are also smart buttons and many other gadgets that were created by the new startups. Also, this do-it-yourself trend is important because it means that many different stakeholders can be involved in creating wearable enhanced learning solutions, not only people from the academia, but also startups, also artists, technologists, and people from different fields, for instance, medical field or other fields, depending on the project. And finally, the third trend that I would like to mention is the Internet of Things. So when we think about wearable enhanced learning, it's again, not only thinking about what the person wears on their body and about this data that can be collected from this one person, but putting those technologies in context. So we have more and more technologies that can communicate with each other. And when we think about Internet of Things, we can think that wearables are just one part or can be part in this ecosystem of smart devices that can communicate. So we can think about learning experiences, for instance, in rooms with sensors put on the bodies of the learners, but also put on in different places of the room, of the building, of the environment around the person. Or even we can take this forward and think about how this can be all embedded in smart cities, where we have technology, smart technologies placed in different parts of the city and can support learning on the go, learning in context, embedded in the environment of a city, for example. Okay, what are the opportunities for learning? I would like to highlight some of the opportunities based on the examples from our book on wearable enhanced learning. So I have just selected a few chapters from this book. The first chapter that I selected is about using smart glasses as assistive tools for undergraduate STEM laboratory courses. And this book chapter describes using smart glasses as a means to visualizing the invisible. Because when you think about, for instance, using smart glasses in physics courses, we can of course make things like electricity and other things visible, more tangible to the learners. So in this specific example, the authors used HoloLens, the AR glasses, and what they did, they designed a series of hands-on experiences with different supplies that you can see on the pictures on the left-hand side to visualize, for instance, the electromagnetic field. And what was possible, the value of this kind of learning experience was the real-time feedback and also attention cueing to different elements in the learning process. And in the book chapter, authors of this chapter nicely link this attention cueing to cognitive load theory and argue and also present some data saying that using AR glasses may be good for overcoming cognitive load and really cueing the attention to the specific elements that we want learners to focus on. The second example is focus on seamless learning. It's from the book chapters on wearable technology in dentistry study program. In this example, the authors used Google Glass, again, AR glass, which was worn by the teacher in the dentistry, medical education, and hospitals. And the value of this specific scenario was the seamless communication between the teacher and the students during work or performing simulated operations, because what was possible to realize was the communication through the AR glass, Google Glass. The teacher could receive incoming messages and could also reply using the voice reply function, and had the hands free at the same time to show other students how to perform a specific step of the surgery, for instance. The third example is from a book, a chapter called Towards Wearable Devices for Multi-Team Systems Learning. And this is another very interesting application of wearables. In this case, the wearables that were applied were proximity sensors that communicated with each other over Bluetooth. The context of this was fire and rescue emergency training. The participants had the sensors in their pockets as seamless listening devices. And the value of this specific scenario was that during an exercise, basically, or training of fire and rescue emergency personnel from of different professions that normally is performed as a simulation of a real-life situation, what was possible was to monitor and to analyze the different patterns of how people actually communicated with each other. For instance, if groups of people were close to the person that required attention or required support, how different groups spread around in a specific environment. So what was possible was to analyze this data and see if there were any patterns that were positive or negative, and this data could be fed back to the participants to enhance, to improve the cross-team behavior in this specific kind of training. Another example is from the book chapter called On the Feasibility of Using Electronic Textiles to Support Embodied Learning. In this book chapter, the authors argue that the textiles that the users can wear can communicate with, can be used to communicate with other sensors in the room. So they can be, this whole scenario can be used to support physical interactions in the room. And this places nicely the wearable enhanced learning in context of IoT, Internet of Things. There are a few scenarios presented that can be used in education, again, to capture traces of behavioral and biological data, for instance, how groups interact with each other, who sits where in the room, what patterns can we define, can emerge, and how can, for instance, group communication be improved. The specific value of this application of wearables for learning is the situational awareness. How, for instance, how do we interact as a group in a room? What can we improve, and so on. The next example is from a chapter called Wearable Technology Meeting the Needs of Individuals with Disabilities and its Application to Education. So the authors of this chapter had a specific focus on visually impaired learners and describe how consumer products can be used to support learners. And there are many different examples in this book chapter. I just picked two of them. One is the Ocram's My Eye, which is a device that you put on any glasses that you wear. And this device enables you to produce text to speech. So the glass can read printed and digital text. It also includes face recognition, product recognition, so it can support people in everyday life, but also in learning, for instance, while reading printed and digital text. The value to the learner is the possibility to assess visual information through hearing. And the second example from this chapter is the application of hearables, which is another group of wearables which we wear in the ears, like for instance, the AirPods. There are many devices that come from the medical field, for instance, to support people with hearing disabilities. So the different hearables or personal sound amplification products can be also used in educational settings. For example, the devices that enable us to amplify sound, but also monitor vital signals such as temperature, heart rate, and translating, can be used in lectures. So when you think about sitting in the large lecture hall and having an impairment, and you sit maybe somewhere in the back, you could use this device to amplify sound. And maybe if you have even difficulties understanding what is said on the language level, you could use this device to support translation. And there are, of course, many similar gadgets or other similar gadgets that support translation as well. Okay, so with all these interesting examples, I hope they were interesting to you. There are nevertheless some challenges that are related to using wearables for learning. And some of the challenges that I'm going to mention were mentioned by the authors of our book chapters. So they're not just theoretical challenges, but they actually come from practice, from research projects that were described in different book chapters. So a lot of times the authors mentioned the problem of availability, access, and cost. Some devices, even head-mounted displays, are still costly to specific populations. Not everybody in the world, in every place of the world, can afford these devices. The second point that is straightforward is the concerns, the problems connected to privacy and personal data, which includes also the biodata, which is even more personal, related to our bodies. And all these questions related to this: where is it stored, by whom it is used, who can misuse this information, and how can we actually make these technologies more safer, and through this also create more trust. Then another challenge is that many wearables that are used are consumer products, and we don't actually know, we cannot look inside and don't know how they are built exactly, how we can, for instance, harness the data, or how we can modify things inside such a consumer product. So they are black box products that we have to use as they come without possibility to adapt to our needs. Then because also of this black box problem, there are products that are just not fit for purpose. For instance, when we use the fitness trackers for our fitness MOOC, we wished they would be, for instance, more possibilities or more other types of data that we could trace, or nicer possibilities, or maybe even possibilities, for instance, to store this data on our own server and do our own data flows, which was not possible. Or people would just apply those products because there is no alternative on the market. So we just experiment with many wearables, and then we in our reflections, in our papers, we say that those products were maybe not the best fit for the purpose. Many authors in the book mentioned the problems of funding for this type of research. It is still new. There are not many funding programs, especially addressing wearables nowadays, and also the problem of scalability. So this we can also see in our book, where many authors report on small projects developed for a specific, maybe for one class or a small group of people. And there's always this issue of how we can make this, the solutions really, they are very innovative, how we can make them scalable. Another challenge that we have is that we, like I mentioned in this fourth phase of wearable enhanced learning, we want to actually liberate the user from the intermediation and make enhanced learning at every place at any time without the need of engaging other parties to support the learning. But a lot of times, what we also hear and observe is that instead of liberating, there's some kind of tethering and even maybe addiction, like in case of people, for instance, overusing self-monitoring and biosensing of their own data. This can also lead to some kind of addiction and maybe overuse of those technologies to monitor daily activities. So that's also a challenge, how to basically strike the balance between those two, tethering and liberation. Another challenge is the ethics of intervention, especially when we think about biosensing data. The question is, do we really know what we are doing? Do we have enough knowledge, enough expertise about what can we actually read from this data, or how this intervention that we are applying can actually impact the person participating in the study or using a specific sensor. So sometimes, or a lot of times, there are ethical questions emerging. Another challenge is language limitations, especially when we think about text-to-speech and applications for AR/VR glasses. A lot of times these technologies come with an English language and are not available in other languages. And finally, there is the issue of social impact. So there are many nice experiments, nice innovative ideas, but I think there is still a large potential for using wearables to really change something on the social level, create social innovation, social impact. And this is something that we are going to hopefully discuss and work on together in the workshop that is coming up after this keynote. So thank you very much for your attention. You have my some of the data here, how you can contact me, my email and Twitter. And I believe I got the time wrong. It's not 10:15, it's probably 11:15, right, when the workshop starts. So, but anyways, it's just quarter of an hour after this session, we have the workshop on using wearables to create social impact. Thank you very much, and I hope we have time for questions.
Oh, thank you so much. There's so much going on, and we do have time for questions. Actually, you do have the time right. It is 9:50 in New York right now, so it's
okay.
It will be 10:50. You did have it right. So,
okay.
So great. Yeah, everybody. Yeah, it was really just a wonderful presentation. We do have time for some questions from the audience. If people have questions, you want to enter them in the Q&A, and we'll see if there are questions that come up. In the meantime, one thing I kind of want to ask you. You know, some of this is more experimental and some of it's maybe a little bit closer to mainstream in terms of potential usage. Are there things that sort of stand out to you in the wearables world as, you know, likely to be mainstream and more available in the near term? You know, when we'll really start to see this, you know, in a more regular way than we see it now.
Yes, it's really actually hard to say because all of these gadgets are already in use. And what I think might be used on more scale are, okay, we have fitness trackers that are very popular. We have head-mounted displays that were already there. I think it's really hard to say, but I think maybe, you know, those gadgets that are like really easy to wear, like earrings or buttons or even the insoles, I think those might become really useful because they are very unobtrusive. You can hardly differentiate them from jewelry or normal insoles, or insole you don't even see what people are wearing in their shoes. So I think this can become more and more popular to wear. Yeah. And it's e-textiles. I think this also, yeah.
Okay, like the smart pants and the kinds of things that you were talking about early on.
Right.
Yeah.
Right.
No. I think. Yeah. No. I mean, that makes sense. You know, to me. Yeah. I think for the reasons that you said, there's always a transition and people getting comfortable with how they are, especially if they're wearing and seeing something new. Like, you know, and it's possible to make the transition, right? Like, you know, the idea that people would walk around with, you know, Bluetooth, you know, earpieces on the streets of New York would just seem, you know, would seem like some other, you know, some potential future, and it became a very common thing. And you know, now you sort of don't even see that anymore. Things are more unobtrusive. But there was a time where everybody was walking around and you would see, you know, these kind of very funny looking Bluetooth pieces sticking out of their heads, and that was totally fine. We do have one question from the audience who wants to know, Paris wants to know, what wearables do you see as being preferable in higher education usage, particularly in the STEM areas?
Yeah, so definitely the head-mounted displays are the most widespread wearable technology that we see everywhere. And it's actually becoming really a mainstream. If you think about the different labs, there are many different projects applying, especially in STEM, physics, chemistry, different for experimenting, for learning in the lab, hands-on applications in the labs. I think those are really the most widespread technology that we have nowadays.
Yeah, and I think, I mean, the definition of mainstream is kind of funny too, right? Because I think mainstream in the world that you're in, probably a little more so than, you know, I think I was thinking kind of everyday life, right? Like, you know, when do we reach the point that like half the people who live in my apartment building have these things, right? You know, everybody has a smartphone, right? You know, does anybody other than me have a, you know, VR headset? I don't know, maybe maybe somebody else does, but it's not everybody. So if they have an earpiece, it doesn't work.
We will see.
Yeah, it'll be really interesting to see how it plays out. And I think your point about, you know, making things unobtrusive is really a big one, and that, you know, helps ease the transition and helps people feel more comfortable. So another question, Christina has a question about embodied learning, the way you're discussing it. Her question is, well, what if people's bodies react differently to things like ambiance or fabrics or furniture, behavior, light, et cetera? So there are things that need to be done to adjust to different people's bodies and the way they react.
Yeah, I think this is really a big challenge, and that's a good question, because whenever you experiment with technology like this and you read the papers, you always hear and you always learn that there are limitations, that the data is not always as correct, the parameters cannot be captured as correctly as you wish, so there are individual differences, calibration difficulties, and all these things that come up in practice. And I think I think in the future there will be probably technologies optimizing the data flows, and hopefully also, like you mentioned, taking into consideration that different bodies may react differently to different things. Like we have those discussions about men and women, for instance, reacting differently, or their bodies reacting differently, or children and adults and senior learners, and how this needs to be taken into consideration when we measure some data and we interpret this data, for instance. But this is the realm of the people in the technical field doing all the medical research, which is it's an interesting thing in wearable enhanced learning, that we work closely a lot of times in projects with people from the medical field, because we need this expertise to actually be able, have the people that are able to read this data and interpret this data in a proper way.
Yeah, absolutely. Let me ask a different kind of question. When you've worked with some of the sort of the subjects of your experiments, or I guess what I want to call them, people who've tested out some of these, how have people felt about trying out different wearable technologies? Do they feel, you know, do some people feel I mean, excited about it, but some people feel kind of, wary about it and uncertain about how this is gonna, whether they even want to put this thing on. So I'm just curious about your experience in dealing with people from the human side of making this kind of adjustment.
Yeah, very, very different actually. It's always surprising to me when we do, for instance, research with senior learners and we ask them, I hope it's not just to make us happy, but they always report how exciting it was to test the new technologies. And sometimes I feel like, wow, they will not like this heavy head-mounted display and the cables around them, but they seem not to care because the experience inside is so captivating and so immersive that they feel like, wow, it was really interesting. I've never tried something like this. So there's this, effect of experiencing something new. And it's also always a question in research, is this something that is motivating and captivating because it's new, and how will it, how are the effects long lasting and sustainable? And again, here we're missing studies, long-term studies and long-term funding, that can really deliver some answers to those questions.
Yeah, that makes it really interesting to see what happens. Christina has a follow-up, I think, getting back to the technology we're talking about with sort of understanding people's bodies a little differently and all of that. When will this be reality is the question. So I think it's a follow-up to her earlier question about the sort of, customized adjustments. I know you don't get to decide that, but do you have a sense of when you think some of those things will be more reality?
I have no idea. I think there's so many different factors that contribute to the acceptance of the people to wear those things, the unobtrusiveness, the trust that nobody is manipulating and misusing your data, and so many, and also, really the value of this also, how is this actually used in context? Because a lot of times when we use the wearables that are consumer electronics, they're just there without giving you any context for use. So you're just there with this gadget, but there's no learning experience designed for you, right? And this is also the question of how this is all used in context.
Yeah, absolutely. No,
so I don't have an answer to this.
Yeah, no, it's a hard one to know. And it is such a critical point, like how, it's easy to get excited about new technologies, even as, as I talked about right before you spoke, but you get excited about the new technologies, but then, what are you going to do with it? How are you going to use them in the ways that will have the greatest, impact? And how are you going to design experience around them? And there's a lot to that. And the better, if you design the right experiences, I think you probably have a better chance of getting acceptance, right? It's still hard sometimes, right? So, there's usually some sort of tipping point, I guess, where people kind of, enough people start to say enough good things that like, I really can use this in the context, maybe it's within an organization or within a university or a particular area where you just get enough, word of mouth. Because we've seen things, right? Like we saw, Google Glass was the next big thing until it wasn't, right?
Mm-hmm.
And
that's a very good example. Yeah. Just the lack of acceptance, the lack of trust. Yeah.
Yeah, exactly. Some of it was lack of trust. Some of it was probably just, it felt kind of strange and goofy. And maybe if there was, like I said, I thought certainly the early Bluetooth earpieces to me looked goofy too, right? But there was enough there in terms of benefit that people, overlook that, right? At least the way that I read it, right? Like that's okay. Yeah, this is worth it. I can walk around and talk on my phone, and I mean, a lot of people like to do this, and I don't personally like to do that, but a lot of people do. So that was worth it to, get used to it, and then it became the mainstream look, right? And Google Glass, I don't know, it was kind of open-ended. There are a lot of different things you can do, maybe sort of kind of soon, and I'm not sure the entire perception maybe quite, got where they wanted to go. So
exactly. But again, those examples, for instance, that were mentioned and that I mentioned today, also from the book chapter, where Google Glass was used in dentistry and medical training, it worked really well. And it was a very positive example, again, where you use Google Glass not just for every day for walking in the street and shooting pictures of random people, but in the context of learning with a real purpose, with some kind of purpose to support learning. So that's, again, my point, that you need to use those technologies in context, design learning experiences with them, and not just throw them at people who use it.
Exactly. No, that's right. And I think that's the key point, I think, to wrap up on. So it is actually just about time. So we can wrap up this keynote session. It's wonderful to have you here for the keynote. Thank you so much. And then 15 minutes from now, 10:15, we will have your breakout session and get into even more detail on. We're really looking forward to that. So Please join us for that, as well as the other parallel sessions starting at 10:15. We also have our ALICE track starting today on adaptive learning, and we have more from the XJTLU University on the University of the Future. So there's so much going on in the next 15 minutes. So we'll let everyone go to break, and we'll see you back in just a few minutes. So wonderful again. Thanks, Ilona, and we'll be back in 15 minutes.
Thank you.
Thank you.